Hello everybody and welcome to my first video. I want to show you a few specs about the Tesla batteries. We start with the form factor of the Tesla is a 18650 used in the Model S and X. It means 18 diameter and 65 in length, and the Model 3 is using a 21700, means it's a bit higher and a bit thicker to have a better energy density. The battery is a combination of parallel and series connection of the cells. Parallel means 4 cells together charged to 4 volt, means 4 volt and 12 ampere hours. Meanwhile, the series with the 4 cells, 4 volts, means 16 volts and 3 ampere hours. But the Tesla uses a combination of both. So here you can see all the cells. It is a total of 86 parallel and 96 in series for the 100 kilowatt hour pack, which means 8,256 cells in 16 modules. One cell is about 50 grams, which is a total of 412 kilos, plus the housing and cooling. There are many different types of cells on the market. Usually you go for a high discharge cell or a high capacity cell on your needs, or something between. Here is the first graph where you can see the capacity. Here is just an example of 6 different cells, starting from 4.2 volts with a discharge of 2 amps. You can see a drop 4.1 to 3.95 and then going down to 3 volts. The longer the graph is, the more range you have. Here are 2 examples from Panasonic batteries, which are the GA is rated at 3.5 and reaches 3.02 ampere hours, means is nearly half ampere hour less than on the specs. And while the Panasonic PF is rated at 2.9, but reaches 2.6 ampere hours. What is also important, here you see a discharge of 20 amps. The voltage is going down a lot from 4.2 with the bad cell to 3.5, which is nearly 0.8 drop. Because of the faster voltage dropping, it has also less capacity. Now I want to show you a video from ScanMyTesla, which I've got only a few days ago, and I have tried to connect it to my Tesla Model X Performance Ludicrous, and I was quite surprised how much the voltage is dropping under a hard discharge. Look, the third bar with the power and the first bar with the voltage. We have a voltage drop of nearly 100 volts, which means divided by 96S, it is nearly 1 volt per cell, which is a lot, using 505 kilowatts only, which means 1751 amps, and 86P is 18.24 amps per cell, and it isn't even in the highest setting. So what would mean 585 kilowatts peak from 380 rear and 205 kilowatts front? I reckon 1950 amps peak or even more, because the voltage drops even more, maybe to 280 volts, and would mean 285 kilowatts. It is nearly 23 amps. The Tesla was at a 90% charge. So how do you calculate the watts? It's just a multiplication of the amps and volts, which means using a high discharge cell would decrease the amps a lot and the volts would be higher, which usually means the car would be faster. More voltage, it is a faster spinning motor, and more amps, it is more torque. But also more amps means thicker cables, more weight, so that's why the Porsche Taycan has 800 volts. Then we see also the temperature increasing with a higher discharge. Of course, this is used on the whole cycle. On the Tesla it's just a short time, but you can see also a higher discharge means higher temperature. The good thing is that Tesla has a cooling of the batteries and can handle this very well. And here you can see a graph of a different discharge from 0.2 amps and up to 30 amps of the LG HG2. You can see the yellow bar, the voltage drops a lot, means from 4.2 to 3.4. I think on my Tesla it dropped even more. In my opinion, the cell can't handle the 500 kilowatt of the car or is over the limit. If Tesla comes with a new plate drive and even more horsepower or kilowatts, they need a bigger battery, because if they use the same 100 kilowatts battery with the same series and parallel, then the voltage drop would be even more. But Tesla said the battery pack is already full, so I reckon they have to put the battery somewhere in the frunk or in the boot, since Maxwell isn't ready yet. And that's also why on the Roadster they use a double-sized battery to handle the discharge better. So on the left bar you can see that the number of life cycles is higher when the discharge is less. Going fast with a Ludicrous model is going also on the number of cycles. But of course it depends a lot of the cell used. On the right side you can see different types of cells, which in the beginning the orange had a similar one than the green one, and the green one loses a lot of capacity within 200 cycles, while the orange one is doing more than 500 cycles. Which cell Tesla is using I don't know exactly, but the discharge drop is a bit disappointing for now. Here is another graph measuring every cycle from two different cells. You can see the blue one is better in the beginning from the capacity, while the orange one has a better life cycle. So what is increasing the life cycle? It is the state of charge. If you charge to 50%, 70% or 90%, which you can choose in your settings in the car and also on the app. I haven't tested 0 or 100%, but I was reading in the internet. Here's a graph of the life cycles. Charging your cell at 4.3 volts allows you only 200 cycles, while charging the cell all the time at 90, it goes up to 800 cycles. And just by charging it 0.05 volts less, you can double your cycles. Here again the settings of the Tesla. 90% in my opinion is already a bit high, enough for 800 cycles. Better is something to 80 or 85%. What is one cycle? Means usually 0 to 100%, or the same is 50-50, 20-80 or whatever. I usually use 5 to 85%, which in my usable full pack readout of the app is 90 kilowatt hours after 7,000 kilometers, which means 80% of 90 kilowatt hours is 72 kilowatt hours, which I use from 5 to 85. I have an average consumption of 24 kilowatt hours. Here are a lot of mountains. I bought the car in the summer and using it in the winter now. Now I'm more on 27, 28 kilowatts, but in the summer is less. And I get an average of 24 kilowatt hours without the heating and discharge loss, which gives me a realistic range of 300 kilometers. If I would charge it to 100%, the range would be 375. Of course, going very slow or without heating in the summer, I could go also 450. What this means after a degradation of 800 cycles, which is about 300,000 kilometers, I just multiplied 375 kilometers with 800, 300,000 is coming out until I have 80% of battery capacity. Means after 300,000 kilometers I should have a range of 240 kilometers using 5 to 85%. But of course there are many factors influencing this, like the age of the battery or the discharge rate or the use of the supercharger. Now let's see how you can increase your battery life. Of course, the Tesla battery management does a lot, like heating up the battery when it's cold outside and cooling when it's too hot. But you can help the system, like with charging the battery in the winter before driving, so the battery is already heated up. Then don't charge the battery to 90 or 100%. As you have seen before, 80, 85 is increasing your life cycle a lot. Lower your charge current means using less supercharger. Of course, it's nice when you're driving around, but usually it's better to use just a plug and charge the battery to a lower rate. And the same is with the disk charge. If you have a Ludicrous model, don't go all the time with the full throttle. As you have seen, the voltage drops a lot and it isn't good for your battery life. Also, it's better to get your battery not too low, and especially not leave it discharged. Means going down to 2 or 3% and then leave it for 1 month. It is bad for your battery.